Hey, so today I want to talk about things that are confusing, to me at least, when I was starting to work with lambdas. Specifically, it's with um, how we capture inside of a lambda. And so the first thing I want to talk about is this example, which is the basic example. And so in basic, inside of this scope here, we're making a variable x equals to 3, and we're capturing it by reference, and then we're going to return x, and that means return the value that's referenced by x, which is 3. But we're just defining f, and so we're not actually evaluating anything. And so down here, when we call f, it's going to try and run that logic. But because of that scope, x will be destroyed, and so the stack memory that was there for x is like freed up, so anything could be written on top of it, and so now that should return garbage pretty much. At the same time, let's make something similar here. So for each number and n, where n is copied from numbers, then let's do the same thing. We're going to capture n by reference. And again, this should not really make sense here because after each iteration, n is being destroyed. And so this doesn't make sense because each time n is like getting clobbered, and that is probably not good. So let's see what happens when we build and run this. So the first thing is f actually runs normally, but clearly the second one does not run normally. And that's kind of what we expected, but the reason why basic did run normally is probably because the stack memory that was allocated for x still is there and didn't get like clobbered. And so when it returns the reference, it tries to get the value at like wherever it's referencing, and it's still there, so it's not an issue. But that's only because that memory hasn't been overwritten yet, and so that really is an issue waiting to happen. A way to fix this would be this, because here now we're capturing by value, which means we're actually gonna store that inside. We're not gonna just like try and reference something, and so now it doesn't matter whether x exists or not because the value is stored within this lambda. And that should correct that, and if we do the same here, that should also correct that. And then let's just build this. So here, that's what we expected. The vectorized version runs properly. And if I did something like this, like here we're just rewriting the numbers vector, and I don't know, what would we expect to happen here? Well, we would expect it to not change anything because we in the lambda we captured by copy, and also this is already copied here, so it's like there's no way that would affect anything at all. And when we run it, that's true. So if we did want that to affect things, what would be our approach? Well, we already know that like putting a capture by reference here wouldn't work because n is just a copy, so it doesn't refer to the memory in numbers. But I guess if we put this would be referring to the actual thing in numbers, right? But we're copying here. We're storing the reference n in this lambda, and we're copying it in. And so we're not really sure what happens here, and I initially thought that this would be fine. So internally this lambda is storing the reference, and I thought that would, just be fine. But when we run this, we'll see that this doesn't work. So this modification that we did here didn't actually update the lambda internally, which kind of implies that what's being stored in here is the value of the reference and not actually the reference itself. And what I did next was I checked the draft here, and if we read this section here, we can see for each entity captured by a copy, and I won't say everything, but the type of such a data member is the referenced type if the entity is a reference to an object. I don't like when they put like what they're talking about after they talk about it. It doesn't really flow with my brain, but what they're saying here is if you have the entity that's being captured, and if that is a reference, then the type of the data member for the that goes in the closure is no longer a reference. It's like the type that is being referred to. So in this case, n is a reference type. It's referring to the type int, like a value with that type. And so the reference type is int. And so what this paragraph is saying here, that is inside of this lambda, the type that's being captured is int. And so to me, that kind of confirms what I was thinking, is that it's no longer having the reference in here, it just has the value. So that's the first kind of confusing thing that you need to wrap your mind around. That's not like, I think a lot of this stuff with lambdas, like, you really don't need to read the spec for C++ to use C++, but like when you're looking at very specific things that could potentially be unsure about, then you kind of do have to start doing that. And so then I was like, okay, so we can fix that by, capturing by reference. And that's a little weird because it's like, so n is a reference, and then I'm capturing by reference. So does that mean it's like a reference to a reference, or like what's going on? So then we can look at some other stuff. So the first thing is, if we capture by reference, then internally to that lambda, it will refer to the identity, which is the captured reference is bound, and not to the captured reference. So I think what's saying is, it's not doing a reference to a reference. It just refers to the one that it's the. It's hard to talk about this because like you're just gonna end up saying the same word over and over, and it like messes with your mind. But when you do this, you're not capturing a reference to the reference. You're just saying that I want the one layer reference. You're not doing like a double layer reference here. That's what I believe this is saying. And then also, the validity of such a capture is determined by the lifetime of the object to which the reference refers, and not by the lifetime of the reference itself. And so here we have an example, and I think this does make sense. We're saying, here we're taking in a reference r, and we know that this reference will exist until the end of the scope of the function. It will be destroyed after that because it's just a parameter. And this is okay. The compiler is not going to have an issue with that, because the internal usage inside of here of R is valid under the lifetime of what R refers to, and not of this reference that's coming in. So, that's making us feel a little better as well. So if we, here, we're capturing n, and it's like by the end of this, it's going to get like deleted. That reference will be deleted, but it doesn't make the internal usage in this lambda deleted, as long as like the underlying thing it's pointing to, which is this, as long as that data, I guess, what did they say? As long as that like the lifetime is still valid for that, we're good, right? So if we deleted numbers after this, then obviously this would no longer be good. But because we just like modify some of the memory, some of the data stored at those memory addresses, it should all be fine because that is still alive, I guess. And so here, this should work, right? So, and yeah, that works. So, I don't know. this is kind of confusing. Like, I don't, you're capturing by reference, and what are you capturing? You're capturing n, which is a reference. So it's not exactly clear like what's going on. So I just wanted to talk about how these captures occur and like the different types you can use, like by reference and by copy. So yeah, this example should hopefully clear things up. So yeah, that's pretty much it.